Hello everyone. I welcome all of you to our session 3, Labor Efficiency and Farm Management in the module Animal Science and Technology. Those who are looking into this video, please check to the session 2 and session 1 as they are all interdependent to each other. So by the end of the session, you will be able to explain how the automation is going to reduce the labor on the dairy farm. We are going to modify the Arduino code, which we had been using in the session 2, to trigger an alert when an activity is going to exceed a threshold. So we're going to set a threshold here, and whenever the activity is going to exceed a threshold, we are going to trigger an alert signal by using an alarm. It's just the replication of what we have learned in the session 2, but along with that activity, we are going to set a threshold here. So automation matters because in the traditional dairy farming, workers manually observe the cow behavior, check for the heat, and record the daily data. So with hundreds of cows, this becomes time consuming and error prone too. So wearable collars plus a farm software can now handle much of that particular workload. Because a collar sensor is going to detect any activity spikes or even the drops, and the farm dashboards, it helps us to generate the automated alerts via LEDs or text messages or any kind of phone-based applications. In this way, the labor savings is happening and staff can focus only on the cows that need attention instead of monitoring all the animals. So we are going to link this particular concept to our circuit by having a tilt sensor and Arduino board along with a management notification kind of any device, either an LED or a buzzer. So let's go to the Tinkercad and start the simulation now. So please go to tinkercad.com, give login, personal accounts, and try to sign in with Google. You can click create and circuits. We are going to use the same components what we have used in session 1 and session 2. But along with that, we are going to use a buzzer here, which activates as an alert. So try bringing all the required components onto your screen. A breadboard, a Arduino Uno, LED, a resistor. Then we will be using a piezo buzzer over here along with the tilt sensor. So the connections are just the same how we did in our earlier experiments. So the ground of the Arduino is connected to the negative trait of the breadboard. The negative traits are connected together. Terminal 2 is connected to the negative trait. And terminal 1 we are going to connect to the 12th pin. We did the same in our earlier session as well. Then we have the anode and the cathode. So we are going to connect this to the 3rd pin. And the cathode we are going to ground. Okay. So with this, connections are done, and we have already done these connections in our previous experiment. That's the reason why I'm going a bit fast. Those who are watching to this video newly, please check to our session 1 and session 2 and then come back to this session, dears. So piezo buzzer will be having two different ends, a positive and the negative one. We are going to connect the negative to the negative trait of the breadboard, and then we have a positive pin which we can connect to any of the digital pins. I'm connecting it to the second one. Again, you can just connect it to any of the pins. So In addition to the session 1 and session 2, we have just included a buzzer here. So this buzzer is going to act like an audible alert for the threshold. Let's start to code this now. So in the real world analogy, the activity level that signals the heat or the stress. So we are going to have a farm system which sends an audible or a phone alert. By using the step count, we are going to log the cow motion or the rumination, and then we are going to start the new monitoring period as well. So this analogy is just like how we have did in our earlier sessions, but in addition, you are going to set a threshold here. Okay. So once the connections are done, please go to the code and then click text. Delete the previously existing code and paste the code which I have shared in the comment as well as in the description. Let's try to understand the code now. Just like a normal Arduino programming, first we are going to start with initialization. So tilt pin is connected to 12. We are connecting an LED pin to the third pin. In addition to that, we are trying to use a buzzer. A buzzer is connected to the second pin over here. Then tilt val, previous val equal to 1. So the meaning of the sixth line is the previous tilt state. Okay, we are storing the value of the previous tilt state. Step count. This indicates the motion count. An animal which is moving and then coming to a rest, and then when it starts to moving again, this indicates like there is one particular step. I hope you are able to get it here. So the animal is moving and then it is coming over to the rest, which means that there is one movement. Okay. And then from resting, it comes back to the movement again. So we are going to count all these steps and keep a threshold for the alert. For example, let's keep the threshold to 5. So once the threshold limit of 5 is being attained, we are immediately going to turn on the buzzer. That's the logic here. So int alert threshold equal to 5. So this is nothing but we are going to set a threshold for alert. Next comes the void setup. So inside the void setup, we have the internal pull-up resistor. I have explained in a detailed way why internal pull-up resistor is required in session 1. Please check all those videos. Then we have the pin mode LED pin output and pin mode buzzer pin output. So the 13th and the 14th line gives us a very good understanding that we are going to configure these pins as the output. Then serial dot between 9600 indicates we are going to have a baud rate of 9600, and you will be able to visualize the output in the serial monitor over here. Okay. Serial.println just throws whatever you put in the codes to the serial monitor. And then we have the void loop. So in the void loop, first of all, we are going to read the tilt sensor value. We are going to read the tilt sensor value and see whether there is any motion change. So from the movement to the resting or from resting to the movement. Okay, that's considered as a motion change. So we are going to deduct if there is any motion change. So the tilt value is exclamatory equal to previous value. So the meaning of the 25th line is we are going to compare the present state and the previous state and see whether there is any changes in the motion. And if the tilt value is equal to low, we are going to increase the step count and print that the movement is deducted. So we have done all these things in the second experiment also. We were trying to count the total number of steps and print all the values in the serial monitor by turning on the red LED. So this is what we have done in our previous session. Next comes a very important logic where we are going to set a threshold here. So if the step count is greater than or equal to alert threshold, so you can see that the alert threshold value here is being set to 5. So if the step count value is greater than or equal to alert threshold, means we are going to check whether the threshold has crossed the trigger alert. So if the threshold is crossed, we are going to trigger the alerts here, and the alert is, we are going to sound the buzzer. Okay. So let's go line by line here. So if the step count is greater than or equal to alert threshold, so we're going to check whether the threshold is being crossed. So if the threshold is being crossed, we are going to trigger the alert here. And print alert high activity detected. Here the threshold value is being set to 5. Okay. And once it is done, we are going to turn on the LED followed by tone buzzer pin, 1000. So the meaning of this particular 45th line is we are going to sound the buzzer of 1 kilohertz. And then we are going to keep the alarm active for some time, and then we are going to stop the buzzer. So turn on the buzzer of 1 kilohertz, then keep the alarm active for some time, then we are going to stop the buzzer. Okay, so that is the meaning of these lines. Tone buzzer pin, 1000, delay 1500, and no tone buzzer pin. So the meaning of these 3 lines is this. Turn on the buzzer, keep the alarm active, and then stop the buzzer. Okay. And once it is done, the LED pin goes low, and then the step count value is being set to 0. The reason is because we are going to reset the count for our next cycle. And then followed by previous value equal to tilt value, followed by a delay. So we have used all these in our previous session as well. So the logic here is from 39 to 50 second, we have learned a concept of if the value is going to exceed the threshold, then we are going to trigger some alert. The alert here is nothing but a buzzer. So turn on the buzzer of 1 kilohertz, keep the alarm active, and then try to stop the buzzer. We are going to reset the count for our next cycle as well. So this is the logic what we have learned today. Let's start the simulation. So you can see there's a total count of 1. So you can see that there's a high activity which is being deducted here. You're getting an alert, high activity deducted over here, followed by an alarm signal. Okay, so this is how a threshold value will be set in the real world analogy. So we have learned how thresholds and alerts turn the data into a decision. Real callers set these kind of alerts to phone. Our simulation here, we have used an LED and a buzzer as the external devices. So on the whole, the automation is going to improve the efficiency where one worker can oversee many cows remotely. I hope all of you have understood this project. See you all in the next session. Until then, happy learning.